No. Okay, so we are doing 7.5. This is the cross product. Previously, we looked at dot product, and that gave you a scalar. Now with cross product, you are getting a vector. So if you don't end up with a vector, there's a problem somewhere. Now, here's your formula in yellow for the cross product. But like before, we're going to have another formula. I'm going to show it after. So this is between the vectors u and v. And there between them is angle theta. Now the end part, this is actually the unit vector of the perpendicular. So if you had two vectors and then you found one that was perpendicular, n is the unit vector of that perpendicular vector. Now how do we find out where these perpendicular vectors are? Because that's what this is, right? The cross product is finding you the perpendicular vector to the two that are given. So how do we find out where that is? So to do this, you're going to be using the right-hand rule. You're going to curl your fingers from U to V, depending on what's given, and that's the direction of that it's going. So this is the other formula. Now this is if you are given it as a Cartesian. So you were given your 3, your x, y, and your z. This is the formula that you have to use. Now don't be scared. I'm going to show you ways that you don't have to memorize. So the first visual way is if you were given this vector A and you were given vector B, again, these would just be numbers, right? 1, comma, -5, comma, 3. If you're going to set this up, you need your I, your J, and your K. So that's your X, your Y's, and your Z's. If we're going to do A cross B, that means our A's have to be first. So it's going to be A1, A2, A3, and then your B's will come second, B1, B2, B3. And notice that the X's, A1 and B1, go with the I. That's the X component. A2, B2, that's J, that goes with the Y component. So they all match up. Once you have this, you're going to take this exact thing and you're going to write it beside it, exactly the same. And that's what it will look like. Okay, so now what you're going to do is you're going to look at the X component. So you're going to come from I, and you're going to go on a diagonal. And you're going to go to J, and you're going to go on a diagonal. K, on a diagonal. And I'm going to switch colors. I'm going to go to green. No, I am in green. I'll go blue. And you go in the opposite direction. I on a diagonal. J on a diagonal. K on a diagonal. And I'm going to dual it so you can see. Look at the first black line and how it connects with what you just wrote. Okay, so the other way that you're going to do it is you're going to take the vectors as they were. So with that, you only need the first part. Then on a piece of paper, you're just going to use your finger. But for this, I'm going to use this box. And you're going to cover up the first section. So when you cover up the first section, this is the I component. And I'm going to get red. If you work on the diagonals, and I'm going to dual it just so you can see. If you work on this diagonal here, A2 and B3, are those not the first two there? A3, B2. It gives you the second one. So with that given formula, do we know what the magnitude of U is? It's 20. Good. Do we know what the magnitude of V is? Do we know what theta is? 25. Do we know what the normal is? What the n is? We do not. So we just write it at the end. We are not given enough information here to solve for n, so the n will just stay there. This is a shout out to Brandon. So that's the answer for that. So if we cover up our I, we do our diagonal. So since we're solving for I, we put an I in front. And we do, on the diagonal, 1 times 6 minus 3 times -2. Then we're finding the J. So we have to slide this over. The only difference with J, instead of adding this, we are subtracting J. But do the same thing on the diagonal. We have 7 times 6 minus 4 times -2 plus Slide it over and solve for the k. So go on the diagonal. 7 times 3 minus 4 times 1. Does that make sense? And that's what you end up with. So we're finding the dot product of those two vectors. And if it equals 0, that will prove that it's perpendicular or orthogonal. So you should get 0. And that makes sense, right? We just did the cross product of s and t, which gives us a perpendicular one. Well, if it's perpendicular to s and t, if we are trying to see if it's perpendicular to just s, will it still be perpendicular? Yep. So if you just have to add those, you add your t components, so your x's, 4 plus the negative 1, which is 3. And then the y components, 3 plus the 2 is 5. And then 6 plus 4 is 10. So you have that vector. And do you have your s vector? Can you do the cross product? So what you should have gotten as the answer is 20, negative 76, 32. Okay, so one other thing to note, gentlemen. It's this right here. Yay. If we have a parallelogram, how can we find the area of that parallelogram? It's by finding first the cross product. Once you have the cross product, then you find the magnitude of that vector. Once you have that magnitude, that is the area of the parallelogram. So after you've completed the cross product and gotten that one vector, and then you find the magnitude of it, bless you, the answer should be approximately 55.7, or your vector should be negative 44, negative 12, negative 32. Monkman, peacing out.